Alright guys, so right now we are going to be covering 2.4, solving systems of linear equations. Previously 2.3, it was kind of just an intro into the school year really. So now this is really kind of an official start, an official first lesson. So solving systems of linear equations. Just one quick note, we're not talking about inequalities today. We're just talking about systems of linear equations. So what is a system of linear equations? A system of linear equations is when you have multiple linear equations, more than two, well, two or more, we'll say that, two or more, that exist on a graph. They exist in the same space, pretty much. And what we're going to be doing is solving for solutions. So what does a solution look like? What does it mean when there is a solution to a system of equations? Well, if we can just for a second visualize what it looks like. If we have two lines, two equations like that exist on a graph, you can see that there's an intersection between the two equations, the two lines. That point of intersection, that is our solution. So the point of intersection is the solution to the system. And the solution is going to be in point form. The solution will be in point form, meaning x and y, because this point is going to occur at some x value and y value. Okay, so what does it mean if there is no solution? Because sometimes you're going to have two equations with no solution. So if there is no solution, that must mean that the two lines do not intersect, which would mean that our equations have the same slope. So again, to kind of visualize what that would look like, it would be having two lines like that. You can see that they have the same slope, so they will never intersect. So that is what it means whenever there is no solution. So no intersection between the two lines. And this tells us whether or not a system of equations is consistent or inconsistent. If it's consistent, there is at least one solution. And inconsistent if there is no solution. All right, so let's go ahead and, well, before we jump into an example, I want to show you on Desmos what three different outcomes you're going to have. So let's have a look at this one right here. So you can see here, these two lines right here, well, they're parallel. There is no intersection, so there's going to be no solution. Okay, right here. Now, over on the left-hand side, I have two equations written out, but you only see one. That is because they are directly on top of each other. So this means that these two equations are the same line. They exist in the same space. So for every point along that line, they are equal to each other, right? They intersect at literally every point on their line because they're just right on top of each other. So in this case, you would have infinitely many solutions. And right here, these are two, this is just what a regular solution looks like, where there's an intersection with the two lines. See that there's a point at that intersection, and that's a solution. All right, now let's go back to our example right here. So we're going to start with just using two equations, two variables right here. And on the right hand side, I have some guided steps that will help us with a process of how to solve for a system of equations. So our first step should be to eliminate a variable. Using these two equations, we can manipulate and add them together to eliminate a variable. So let's go ahead and look at what that looks like. So to eliminate a variable, you get to pick which variable, whether it be x or whether it be y. That is up to you, but we have to be smart about it to make work easy, right? I'm a pretty lazy guy, so I like to make work as easy as possible. So I am going to find a variable without a constant. So you see on that bottom equation, this x right here does not have a constant. Well, that is going to make our life really easy to manipulate and to add equations. So to manipulate, I'm going to multiply this bottom equation by -2. Because if I multiply this by -2, I'm changing the equations. I'm more like changing the numbers of the equations, but the equation is still staying the same. That's what it means to manipulate it. So let's go ahead and write this again. So our top equation, we're keeping the same. 2x minus 3 is equal to 3. Now we're going to multiply every single element in this equation by -2. So -2 times by x, -2 times by 2y, which would be -4y, which is equal to -2 times by 5, which is -10. All right, now notice here, they're opposite signs, but with the same constant, right? And with the same variable. So if we were to add these two equations together, well, 2x minus 2x, that's 0. -3y and -4y, that's -7y, equal to 3 and -10. It's going to be -7. So whenever you're adding, before you even attempt to solve a system of equations, make sure your variables line up. So you have your x's, your y's, and your constants. And notice here, we eliminated a variable. And now we have one equation with just one variable. So now we can solve for the y. So if we divide by -7 on both sides, that's 1. So y is equal to, well, -7 divided by -7, well, that is also 1. So y is equal to 1. There we go. We just completed step 2. We solved for a variable. All right, but we haven't finished, because remember what I said earlier, that an equation, the solution is going to be a point. There's going to be an x value and a y value. We only found the y value of where this intersection is going to take place. We have to find the x value. So what we do is we plug this value that we have for y back into one of the two equations that we had up here. We can pick whichever one. I'm going to pick the bottom one because, again, I don't have a constant next to my x, which makes it easier to solve for. So I'm going to write that one equation down. X plus 2y is equal to 5. Well, we said that y is equal to 1, right? X plus 2 times by 1 is equal to 5. X plus 2 is equal to 5. Minus 2. Minus 2. X is equal to 3. And now we just need to write our solution in point form, not post form. Sorry about that typo, point form. And I keep doing that. So we have our x and our y. And there we go. That is our solution. So these two lines will intersect at the point 3, 1. Okay, now, hopefully I don't lose you guys here. We're going into some pretty abstract territory because we're going to be focusing here on learning how to solve for linear equations in 3 variables. So we have an x, a y, and a z. So whenever you have an x variable, x and y variable, well, you're just talking about an xy plane, right? But we're talking about a third variable, z. So there is going to be, if you can imagine, another variable right here. And now we're existing in a 3D space. So this is going to get kind of funky. So follow me here as best as you can. And go back and watch this if you have any questions. And then come to class prepared to ask me questions. So what does a system of 3 variable equations look like and their solutions? Well, in 3D space, these equations are going to look like planes instead of lines. Whenever we had just 2 variables, we were looking for the intersection between 2 lines. But in a 3D space, we're going to be looking at the intersection between the planes. So this equation right here is a plane, not a line. So if there is exactly one solution, well, you can see here that you have the red plane right here and the green plane and the blue plane right here. And those are all intersecting right here at that one point. That is our solution to a 3-plane system of equations. You can see here that just the green and the red are intersecting. Right here, it's just the blue and the green intersecting. Right here, it's the blue and the red. But at this point, it's all 3. Now let's go over to the right where we see an infinitely many solutions. Where right here, you're going to see all 3, the green, the blue, and the red plane are all intersecting right there. And that solution is going to be a line instead of a point. And since it's a line, it has infinitely many solutions. And down here on the bottom is what it looks like whenever you have no point in common. Because you can see in this first one right here, the green and the red are intersecting, but not the blue. Over here, the blue and the red are intersecting, but not the green. Right here, the green and the blue, but not the red. On the middle one, you have the green and the red, you have the blue and the red, and that's pretty much it. The green and the blue planes do not intersect. And then over here, nothing intersects on the far right. So this is what I want you to visualize whenever we're working in a 3D space. So we don't have to graph this out. You won't be asked to graph any of this, but that's just what it looks like. Now let's move on to how to solve for these. And we're going to follow the same concept and the same steps as we did whenever we just had 2 variable equations, but it's kind of just doing it twice over whenever we have a third variable. So this is finding a solution with just one solution. So like this one right here. Okay, so we have our 3 equations, which are planes. Now, we want to eliminate a variable, but we want to pick 2 equations first that will help us eliminate one variable. Take it one step at a time. So identify 2 equations to eliminate a variable. Well, for me, again, I like this equation right here because guess what? That doesn't have a constant next to it. And then I want to pick one of the other 2. Well, I'm going to pick this one right here. So I'm going to write those 2 equations. So I have 4x plus 2y plus 3z is equal to 12. 6x minus y plus 4z is equal to negative 3. Okay, so now we're going to follow the same exact steps as we did in the other one. We're going to eliminate a variable by manipulating one of the equations and then adding the two. So again, this is why I chose this one right here, because it doesn't have a constant, so it's easier to manipulate. So right there makes it easy. We already know which variable we want to eliminate, which is our y. So I'm going to multiply this by 2. So I have 4x plus 2y plus 3z is equal to 12. Now, 2 times 6, that's going to be 12x. 2 times negative y, that's going to be negative 2y. 2 times 4z, that's going to be plus 8z. 2 times negative 3, which is negative 6. Okay, so let's go ahead and now we can add these two equations together. Well, 4x and 12x is 16x. 2y, negative 2y is 0. 3z and 8z, that's going to be 11z plus 11z, which is equal to 12 and negative 6 is 6 right here. Okay, I'm going to highlight this right here. I'm going to add a 1 and circle that. And we're going to come back to it because this is a new equation. Okay, don't forget about that one, but we're going to circle back to it. Now we are going to identify two different equations and eliminate the same variable. We're going to go back up to here. Now it's okay if you use one of the same equations, but you can't use the same two. So I'm going to stick with this one because I like that the y doesn't have a constant next to it. But I'm going to choose the other equation. So I'm going to take these two and do the same exact thing. 2x minus 3y plus 5z is equal to negative 7. And then we have 6x minus y plus 4z is equal to negative 3. All right, now we're going to do the same thing, manipulate and add. So I'm going to multiply this by negative 3, but one thing to remember that we have to get rid of the same variable that we did for this equation right here. The same exact one, or else this isn't going to work. So we have to eliminate the y again. So 2x minus 3y plus 5z is equal to negative 7. Negative 3 times 6x is negative 18x. Negative 3 and negative y, that's going to be positive 3y. Negative 3 and 4x is negative 12z. Negative 3 and negative 3 is positive 9. Okay, now let's go ahead and add the equation right here. So we're on this step right here. We manipulated the equation. We're going to add these two together. So 2x and negative 18 is negative 16x. That's going to be 0. Then we're going to have negative 7z equal to 2. All right, this is another new equation right here. So we have the 1 and the 2, another new equation. So for our fifth step, we're going to write down both these equations. 16x plus 11z equal to 6. Negative 16x minus 7z equal to 2. So these are two new equations, and notice now, look how many variables we have. We just have two variables. So we're back to doing a system of equations, but with only two variables, just like we did before in the previous equations, in the previous example, sorry. So now we just have to follow the same steps. Let's eliminate one more variable and solve for the remaining variable. In this case, it's going to be easy because we already have our x values ready to be eliminated. So let's just go ahead and jump straight to that where we eliminate, add them together. That's going to be 0. We have 11 and 7z, that's 4z, equal to 8. Now we can solve for z. If we divide by 4, it goes to 1. Z is equal to 2. There we go. We have one part of our solution. Now, just like we did before, in the last example, we just had to plug this variable back into one of these two equations, and you can pick which one. But I'm going to choose the top one, the positive 16, because positives are easier, and we're solving for x now. So 16x plus 11. Now we know that z is equal to 2. So I'm going to put 2 right there, equal to 6. Okay, well, 16x plus 22 is equal to 6, minus 22 from both sides goes to 0. We have 16x is equal to negative 22, and 6 is equal to negative 16. Divide by 16. And there we have that x is equal to negative 1. Okay, so now we have z and x. So plug in the solutions for the two variables that we have back into one of the three equations that we have. So we go back up here and we see our three equations. We have already solved for two of the variables. So now all we have to do is plug the answers for two of those variables back into one of these three equations. Again, you can choose. So I'm going to choose, let's see, I'm going to choose the bottom one because, again, y doesn't have a variable or a constant, so easier to deal with. So let's go ahead and write that. 6x minus y plus 4z equal to negative 3. Is that right? Yep. Okay. So let's go ahead and plug in what we have. So 6x minus, we know what x is. So 6 times by negative 1 minus y, that's what we're trying to solve for, plus 4, z was 2, equal to negative 3. Okay, 6 times negative 1, that's negative 6, minus y plus 8, equal to negative 3. Let's go ahead and subtract 8, and while we're at it, let's go ahead and add 6 to both sides. That's going to be 0, that's going to be 0, so we have negative y is equal to, what is that equal to? 2 times 3. I think I accidentally wrote this down wrong. Here, let me do this in a little bit of a different way before we go crazy and do too many functions at once. So negative 6 and 8, let's go ahead and add these while they're already on the same side. So we have negative y plus 2 is equal to negative 3. Let's go ahead and minus 2, negative y is equal to negative 5. And then divide by negative 1, or you can multiply by negative 1. So that's going to make our y positive and change the sign on our 5. So y is equal to 5. And there we have it. We have found the solution to this. So we had x, which was equal to -1, y, which was 5, and z, which was 2. And that is the point where three planes will intersect. Okay, now let's go over what it looks like whenever you get no solution in this space. So we already showed you visually, so I want to show you what it looks like when you're trying to solve. So we're going to follow the same exact process. Pick two equations to eliminate the variable. Well, let's look at all of our equations. So we have, oh, look at this one right here. That's an easy equation to use because it has no constants in front of the x, the y, or the z. So that's definitely a must. So let's just go ahead and use that one. X plus y plus z is equal to 2. And we'll use these two equations, and then we're going to go ahead and use those two equations. If we even get that far, we'll see. So let's take those two equations. And then we have 5x plus 5y plus 5z equal to 3. So notice that in the second equation that all the constants are the same. So this is looking a little bit different already. Now we're going to manipulate and add to eliminate a variable. Let's just pick one of them. Let's just say x. So let's do, to eliminate the x, it has to be negative 5x. So let's multiply this by negative 5. So when we do that, we get negative 5x minus 5y minus 5z equal to negative 10. So I can already see that this is looking weird because then we're going to have 5x plus 5y plus 5z, which is equal to 3. Now, let's add the equations. Well, that's 0, that is 0, that is 0. And then, so this whole side is 0, but this side over here is going to equal negative 7. Now, let's ask ourselves the question right here. Is this statement true? Does 0 equal negative 7? Hopefully you answered no. So this is a false statement. Therefore, we're not going to get a solution. We just solved this. We eliminated all the variables when we tried to add the equations, and we got a false statement. So the system has no solutions. All right, so that wasn't too bad. Okay, we're going to do one more example covering mini solutions and what that will look like. Again, we're going to follow the same exact process. Identify two equations, eliminate the variable, pick another two equations, eliminate a variable, and then we're going to take those two equations, eliminate a variable, solve for one, and work our way back. So let's identify two equations. Well, I'm loving these two right there. And already this is looking kind of weird. So let's go ahead and take those two equations right here. So we have x minus y plus z is equal to negative 3. X minus y minus z is equal to negative 3. All right. Sorry, yep. So the only difference between these two is that plus sign. Let's see where this leads. So we have to manipulate the equation. Let's just say we want to get rid of the x. So if we multiply, let's multiply this. Oh, wait a minute. Look what we have here. We can just go ahead and go straight to adding because of that right there. we can eliminate our z. Sorry. Good thing I caught that. We were going to do extra work that we didn't need to do. So let's go ahead and add these. Well, x and x, that's going to be 2x. And then we have negative y is negative 2y. These are eliminated. So we have equal to negative 6. Okay, this is one equation right here. We just need to find another equation using the two other equations. So we already used those two, so now we're going to use these two right here. You know what? I'm actually going to use these two right here. I think that will work better. Well, let's go ahead and find out. Again, you can use either. So if I use those two right there, let's go ahead and write those out. So we have x minus y minus z is equal to negative 3. 5x minus 5y plus z is equal to negative 15. All right, we're going to follow the same process. We eliminated z in the two equations before, so we have to eliminate z now. And so look again what we have here. We can just add, go straight to adding. We don't have to manipulate. Go straight to adding and then eliminate our z. So if we add these together, that's 6x minus 6y. That goes to 0, equal to negative 18. So this is our second equation right here. Okay. So now we have to take the two equations and solve for both variables. So equation 1 was 2x minus 2y. It's equal to negative 6. And then 6x minus 6y, which is equal to negative 18. All right, so we have two variables. We're going to treat this like a two-variable system of equations. Let's go ahead and we want to, let's say we try to eliminate dx. So this is 2x, and right here is 6x. So in order to eliminate, this right here needs to be negative 6x. So we're going to have to multiply this by negative 3. So negative 3 times 2x is negative 6x. Negative 2 times by negative 2y is positive 6y. Negative 3 and negative 6 is equal to 18. And then 6x minus 6y is equal to negative 18. So hopefully right now you can see what's going to happen. Kind of similar to a solution with a system with no solutions, but just a little bit different. Because if we go ahead and add these together, because we can, well, that's going to be 0, that's going to be 0, that's going to be 0. So we have 0 equal to 0. If this ever happens, that means you have infinitely many solutions. So, there you go. There we've covered one solution, infinitely many solutions, and no solutions. And then in the next lesson, we're going to be covering substitution. All right, thanks guys. That's it for today.